break-even point, a fundamental tool for analyzing the cost and revenues of a business. In today's lesson, we'll explore the difference between fixed and variable costs to understand how they behave relative to production, the concept of contribution margin, which will help us calculate the break-even point, how to calculate the break-even point using both a formula and a graphical representation, and finally we will look at the practical applications of the model with a hand-on example that solidify our concepts. Let's start with the basics. To calculate the break-even point, we need to understand how business costs work. Fixed costs are those that do not change with production levels. Essentially, these are costs you incur regardless of whether you produce 1 unit or 1,000 units. A classic example is the rent of a location or a communication campaign. If the rent is $1,000 per month, it stays the same, regardless how many units of your product you will sell. The same applies to fixed salaries or insurance expenses or other marketing investments. Variable costs, on the other hand, depend directly on the quantity produced or sold. The more you produce, the higher these costs. Think of raw material costs or electricity or the percentage that you give to your sales force or any costs that changes according to the units that you are going to either produce or sell. For instance, if raw material costs $5 per product and you produce 10 pieces, the total cost is $50. If you produce 100 pieces, it rises to $500. This distinction is crucial because it helps us figure out how much we need to sell to cover all the costs, the total costs. Now let's move to the second key concept, that is the graphical representation of the break-even point. In a space we can represent the relationship between the units produced and sold on the horizontal axis, and on the vertical axis the costs expressed in terms of monetary costs. But since they are money, we will also use the same vertical axis for representing the revenue. Let's start representing the costs. The variable costs are the line with a specific slope that you can see. It starts from the origin of the axis, because if we don't produce any unit, we will not have any variable cost. Variable cost increases as the production of units increases too, because this is the definition of variable cost. While the fixed costs are represented with a line that is horizontal and it is parallel to the horizontal axis, to the units, because the fixed costs do not depend on the units that are produced. They always remain the same. So the total costs are represented with a line with a specific slope, where the slope is the amount of variable costs, and this line starts where the fixed costs meet the vertical axis, so at the level of the fixed cost. This is the line of the overall cost, the total costs. We can represent also the revenues. Revenues are price per unit times the units sold. So if we don't sell any unit, we don't have revenues. So the line starts at the origin of the axis and it increases as long as we are able to sell units. So for 1 unit, the money is equal to the price. For 2 units, the money, the revenues are equal to 2 times the price per unit. 3 units sold, the revenues are 3 times the price per unit, and so on and so forth. What we can see in what is represented here is that the line, that is the green line of revenues, stays below the red line of the total costs until a specific moment that can be expressed, represented by units, when the green line passes through, so becomes than the red line. That means that for a specific amount of units, revenues are more than the total cost. What is represented here is exactly the break-even point. Where there is the crossing between the two lines, we have the amount, so the total units that must be produced and sold for covering the total costs. The crossing of the two lines is when the profit is zero, when revenues, total revenues, are equal to total costs. What happens for units that are below the break-even point? Well, this is the area of losses, so we lose money because the total revenues are not able to cover the overall costs. Each unit is able to cover the production costs in terms of variable production costs, but it is not able to cover the overall fixed costs, so we have losses. Once we reach the break-even, so we have been able to sell an amount of units that cover the total cost, we start getting profits, and that is the area of profit. It is on the right side of the break-even point. So the more units we are able to sell, the bigger will be the profit that we will take home. The graphical representation is able to provide us with some insights about the changes in price. When the price increases, it means that the slope of the line becomes steeper, so the green line meets the red line earlier. That means that we need to sell a lower amount of units in order to cover the total cost and to start getting profits. When the price decreases, it means that the slope decreases, so it is less steep the line of the revenues. That means that the cross happens later, and the units that we need to sell for starting getting profit, so the break-even point, increases too. You can see looking at these two graphs. When you compare a price increase and a price decrease, you can see that basically when the price increases, we need to sell less units before starting getting profits. When the price decreases, we need to sell more units before starting getting profit. And this is because of the mechanism of the contribution margin. Obviously, we are assuming that the total cost remains the same. Let's start estimating the break-even point with the algebraical formula. We said that the break-even is the total amount of units that must be sold in order to cover all the fixed costs and starting getting some profit. That means that the profit at the break-even point is equal to zero. We do not have profit. If the profit is zero, it means that the total costs are equal to the revenues, total costs. That is the sum of the fixed costs plus all the variable costs for producing that amount that is equal to the break-even. And for us is the amount that we want to estimate. So if total costs are the same as revenues, so are equal to the revenues, the profit is zero. But we can substitute the revenues with the formula of the total cost. The total costs are the sum of the fixed costs plus the variable cost per unit times the quantity that is produced, and we assume that it is also sold. In this case, revenues are price per unit times the quantity that are sold. If we apply the formula, the fixed cost plus the variable cost per unit times the quantity must be equal to the price per unit times the quantity. This condition is the condition that makes the profit equal to zero. How can we develop this formula? Well, if you group Q, that is what you want to estimate, you can see that Q is equal to the fixed costs divided by the price per unit minus the variable cost per unit. let's move to the contribution margin. The contribution margin tells us how much each product sold contributes to covering fixed costs and eventually generating profit. The formula is simple and it is represented in the slide. The contribution margin is equal to the selling price per unit minus the variable cost per unit. That means that what remains after having covered all the variable costs for producing that unit, what remains is used for covering the fixed costs. Why is the break-even point so important? Here are three key reasons. First of all, it helps to determine the minimum sales volume needed to avoid losses. It's a useful tool to evaluate whether a new business or product is economically viable. That means, will we be able to sell the minimum amount for covering all the investments required, where the investments are the fixed costs? If we will be able to sell this amount and even more, well, the project is profitable, otherwise not. Is it a useful tool to evaluate whether a new business or product is economically viable, and it aids strategic decision making, such as reducing fixed or variable costs or increasing the selling price. However, the model has some limitation, and it assumes that costs and prices remain constant and doesn't account for factors like market demand or competition.